Awesome. So welcome. I'm so excited to be here. My name is Kellyanne Mahoney, and I'm a youth program specialist at Autodesk. So today we're going to talk a little bit about the concept of biomimicry and how particularly architects, engineers, and people who work in the construction industry use nature as an inspiration for the work that they do. But today I wanted to start off talking about robotics a bit, and I've tried to include robotics throughout the presentation today because I am so happy to be interacting with brilliant young roboticists in New Hampshire. So I thought that we'd start out just kind of in the chat to just discuss what are some ways that you can think of that nature can inspire robotics. So please let us know in the chat. So Pete, has anybody responded in the chat to the question yet? All right, well, you still might be processing out there, so I'm going to continue with the presentation, but Pete, please feel free to interrupt me and let me know if anyone has anything interesting to say on the topic of nature and robotics. So again, my name is Kellyanne Mahoney. I'm a youth program specialist at Autodesk. We're going to talk a little bit today about biomimicry and using nature as a design partner. Takeaways for today. I'm hoping that we can discuss ways that analyzing and imitating nature can help solve problems. We're also going to discuss a little bit about how robotics is being applied within the AEC industry. So that's the architecture, engineering, and construction industry. I know that all of you roboticists are out there are probably very familiar with the idea of how different technologies are converging with one another and also different industries. So we'll talk a little bit about that today. And finally, I'm hoping we can have fun watching me create a 3D model within Tinkercad so that you can think about how you might integrate 3D design into your work too. So again, this is me. If you want to learn more about Autodesk, if you want to learn more about Tinkercad, which is actually the product that I primarily support at Autodesk, or connect with the Autodesk education community. These are all our handles on Twitter and Instagram. Sorry, I'm not as cool as you guys with some of your other social networks that you use, but these are all of our handles. And I'm going to share with you some more information at the end too to connect with us. So I work for Autodesk. We are a software company. We make software for people who make things. Our customers make, all types of things from high performance cars or, electric cars. The Shanghai Tower, for example, was designed using our software. So in the building industry, bridges, and also the computer graphics in some of the blockbuster films that we enjoy or the video games that we like to play. So there's all types of things that our customers do every day with our software. But we're going to start with Tinkercad. I know that many of you might think Tinkercad is like, oh, that's the 3D design software for kids. But I hope that you come away realizing that you can actually use Tinkercad as an interesting tool for conceptual design and for quick prototyping. So you could design a car using Tinkercad, and you could be designing it for it to be 3D printable. You can have fun in Tinkercad without having a 3D printer. So I want you to take that away too. You could practice your architectural skills using Tinkercad. You can measure things. You can think about the type of math that one would use. If you were thinking about being an architect, you could design things that are structural, so things like bridges. You could also use computational thinking in your design using the Tinkercad code blocks environment. So that's what you see here in this animated GIF. So something like a bridge, if you're designing a bridge in Tinkercad, you could actually even bring it to life in reality, not through a 3D printer, but maybe just using your digital model as kind of a blueprint and using things around the house like popsicle sticks or, Kiva planks or Legos in order to build your bridge. And lastly, I think that one of the most fun things about Tinkercad is it allows you to express yourself through STEM. It really puts the A in STEAM, so the arts and science, technology, engineering, and math. And I just wanted to show you guys this really quick. I saw this on our Tinkercad Slack yesterday. So some of our Tinkercad, members of our Tinkercad community are real power users. So I did want to show you this car was actually designed using Tinkercad. It was analyzed by our Tinkercad team. So just to kind of, for you to take away from this, that even some adults who are able to use kind of some of our more sophisticated software really enjoy playing with the constraints of Tinkercad and seeing how, what things that they can make. Any questions or anything interesting in the chat so far, Pete?
Yep. So we had two items. One was idea was motion modeled on insects, and the other was watching how groups of bugs like ants move together to accomplish a task.
Interesting. And that was actually, those were microbots that I showed at the beginning. So not just thinking about like the forms of nature, but also even thinking about the processes in nature. So the idea of like swarming, for example, or even some of like the modular components of things like snakes, or like even gross things like cockroaches are influence the way that roboticists are working today. Anything else, Pete, before I move on?
Nope, not yet.
Cool. All right, so also just want to make clear to you as well that Tinkercad is free for everyone. It's web-based. It works really well in Chromebooks, for example. I know a lot of you guys are constrained to Chromebooks at this point, in this place and time during distance learning, but you do all should have free access to over 100 of our professional tools. So if you really enjoy using Tinkercad, you can move on to Fusion 360. And also I'm going to talk to you a little bit about some of our other products in the AEC, so the Architecture, Engineering, and Construction Collection. But before we begin, I thought that we would talk a little bit about math and patterns and start with Fibonacci. So you're all in high school, so you're probably familiar with Fibonacci. So he's a mathematician. He was working 850 years ago in Italy. And he was someone who is thought of kind of like as a pioneer of this sort of concept of biomimicry and finding patterns in nature. And the animal that he was particularly interested in was rabbits. And he was particularly interested in the replication of rabbits. So thinking about the mating patterns of rabbits and the way that they reproduce, and then thinking about the pattern of numbers that starts to form when you really analyze the way that rabbits are replicating. So one of the things that he noticed was so if he had one pair of rabbits, after the first month, there would still be one pair of rabbits in a confined space. After the second month, there would be still one pair of rabbits if they were in a confined space. After the third month, there would suddenly be two pairs of rabbits. After the fourth month, there would be three pairs of rabbits. After the fifth month, there would be five pairs of rabbits. Can anyone guess in the chat what the next number is in this sequence? I'll give you a visual clue. Anyone guess what number is missing in this pattern in that green box in the upper right-hand corner? Any guesses, Pete? So what number is missing? So we have 1, 2, 3, blank, 8. You can also analyze the squares, even thinking about square roots, and try to figure out what number is missing. Nothing yet? Well, for the sake of time, I will give you the number. So it's 5. So when we think about the Fibonacci sequence and finding patterns in nature, this is actually a representation of the golden ratio. And when we think about, the type of work that you might be doing in construction or in architecture or in, even designing products or even in art, one of the things that designers have noticed is that this pattern of numbers and this ratio, so thinking about the relationships between numbers and also the relationships between proportions and shapes, tends to kind of inspire designs that are influenced by the golden ratio. So we also talk about angle. So this is another golden number, and you'll see me when I rotate in Tinkercad that I'll be using angles in rotation. So this is the golden angle. So 137.5 is the golden angle. So we see that in math. We also see this in plants. So when we look at a plant like a succulent, for example, which you see here, if you were to measure the degrees around the way that the leaves are arranged on the stem, you'll realize that they are at this 137.5 angle. We also start to see this in universal symbols and also in other areas of nature. So for example, this is the nautilus shell. In the nautilus shell, we can see that, kind of thinking back to that image with the rectangles and squares in it, that you can see that in the spiral of the nautilus shell. So this is my deep thoughts question. So feel free to continue telling us your deep thoughts in the chat. So why do you think this pattern recurs in so many places? So a lot of times when we are, thinking about robotics, I know that you're doing a lot of computational thinking as well. And, a key foundational knowledge in computer science is thinking about patterns. So why do you think this pattern recurs in so many places? And why do you think it's important that we recognize universal patterns that exist within our world? So please keep it going in the chat and let us know what you're thinking, all of your deep philosophical thoughts. Anything deep so far, Pete, in the chat that we should talk about?
Nope, we've got a little bit of delay in the chat though, so we did get 4 responses of 5 for the Fibonacci sequence. But I think our delay in posting questions might be on the order of 20 to 30 seconds.
All right, no worries about that, Pete. And please feel free to engage with each other too. So this is just an example in Tinkercad of something that a design that I made just kind of quickly inspired by the numbers in the Fibonacci sequence. And I was doing that through measuring the size of the squares and then just seeing what happens when I put one next to the other. I think I was messing around with the heights as well. So this is just some more imagery from Tinkercad. Yep, Pete.
Oliver says because they're functional.
Because they're functional. So, and we're going to actually see an example of that later on, how in the construction industry, we're able to analyze buildings in order to make them more efficient and more functional by finding patterns and then trying to simplify those patterns as well. So thank you. Keep it going in the chat. For those of you who are interested in coding, we do have an environment within Tinkercad that's called Tinkercad Code Blocks, and I'm going to show you this now. This is a cool biomorphic or biomimetic design that was created by an architect. So her name is Ola Jensen, and what I want you to do is just look at what's happening on the screen. We'll see in a moment. And just try to think about, sure, yep.
Yep, so Jeff says there are only so many patterns in nature. The same formulas can be applied across many fields.
And that's sort of like analogous thinking. So the way that you're finding an example of something even in like one industry and then like thinking about how we could then take that and apply it to a different industry is really important for innovators like you, and thinking about those analogous situations. So how can I take this one thing in this industry that seems very different than this other and make that connection? So I'm really glad that you are doing that sort of divergent thinking, which is so important. And I'm sure you're doing this part because you have learned so much through FIRST. So what are you noticing that's happening here? So on the left-hand side, we see, some block-spaced code. And then on the right-hand side, we see what it's doing. So anything interesting, let us know in the chat what you're noticing. Maybe it's even just in some of the math that you're seeing. This architect clearly paid way more attention in math class than I did because I can't quite figure out exactly how this is working, but I like to watch it and try to figure out every time what she's doing and why she's doing it. So what are some things that you notice? What do you think she made too? What do you think that this is a representation of? So it's a pretty cool shape. What are we seeing? Pete, anybody? I know that we're on a delay, but anything anyone has to say about this design?
Not yet, but is that fractal based?
Well,
it's like a
yes,
phase built up of circles, of spheres.
Yeah, it's a base. And one of the things that I think she's also really interested in is in thinking about the way that the spheres were kind of moving around in one direction, and then it seems like it's going in another direction. What she was actually designing, oh, and this is actually just meant to show you that if you found that interesting, so Tinkercad code blocks, you can get started in Tinkercad if you go to activities, and you can make some really interesting designs, particularly like 2D designs, so things that are really complex that might be harder to create through the 3D editor. So things like snowflakes, for example, stuff that you might want to laser cut or die cut. So what she was actually designing was a sunflower. Did we have any other guesses?
We had a guess of a raspberry.
It did look like a raspberry, particularly the shape. And I would actually argue that it kind of looks a little bit more like a cone flower if you really want to think about it within the context of flowers. But what she was doing was actually, she was inspired by the math of a sunflower and the way that the head of a sunflower is constructed. And if you look really closely at a sunflower, there is this spiral of what we call the florets, which is where the seeds come from, in the middle. And if you look really closely, there's actually two spirals and they're going in opposite directions. And if you look at a smaller sunflower, there may be, if you look at that white set of spirals, there are 21 going in like a clockwise direction. And then there are 13 going in a counterclockwise direction. Those numbers could change as the sunflower head gets bigger, but those numbers are going to fall along the Fibonacci sequence as well. And what you were noticing in terms of like kind of the basal structure of the sunflower is that the way that these spirals go one way and then in another direction, it creates almost kind of an interference of one kind of pattern laid over the other that makes an optical illusion that gives us this sense of even more depth than, you know, what we might actually see if we touched it in real life. So architects are also, oh, sorry, Pete, yeah.
Sorry, so the question that came up was if there's, if you can do a posting in the resources section of the Whova, either, I don't know, if of links to the presentation or if there's any on the Tinkercad site, if there are any links to this content.
100%. So there's actually, I contributed a lesson to the lesson plans for teachers, but you know, this could be something that students could access too, because they're self-directed. There's a lesson if you go to Tinkercad Teach, and I can post in the chat later on, but Tinkercad Teach, if you go to the lesson plans, the first lesson there is actually biomimicry and using nature as a design partner. So there's even more information there about this presentation today. But I'm glad to, I know that this is being recorded as well, so the recording you'll also be able to access later. But yes, please go to Tinkercad Teach and go to the lessons. Anything else, Pete?
Another. Actually, this is for me, but on the sunflower buildup there, it looked very interesting to me that there were basically, it was constructed using a variety of conic sections. So there were spheres, and then was the main bowl shape hyperbolic, and those and those are all basically cuts through a sphere, different types of cuts through a sphere, conic sections.
And it's just every time I look at that animation, and you can create an animation like that of your computational thinking on Tinkercad code blocks. It's really easy and interesting. Every time I look at it, I see something new in it. So it's interesting coming at it from different perspectives. I will let you all know that I was an English teacher. I was a middle school English teacher before I joined Autodesk. So my background is a little bit different, but isn't it fun when you get into conversations with people from different perspectives and we all kind of see, different things when we look at it. So that's really cool, Pete. Thank you. So moving on, so talking about architecture. So there's an architect, Salah Masumi, who actually took that concept of the way that a sunflower is constructed and also thinking about why. So when we think about that structure of the 13 spirals and the 21 spirals going in different directions, we think about, well, it's one of the reasons for that is it's a really efficient use of space because the sunflower is trying to get as many florets as possible within that, the constraints of that, the sunflower head. But then how can we apply that? Like how someone was saying earlier, how can we take a pattern in one place and think about how we can apply it in another, and maybe it's for a different purpose. This architect was thinking about, and this is a rendering, this is an actual picture of the building, but he came up with this concept of this tower with all these balconies, and thinking about the problem of if you're living, in an urban area in a tower with balconies, that not every balcony, if you have one balcony on top of the other balcony, then you don't get as much access, to the sun, or you might even get too much sun and not enough shade. So he thought about, how can I apply this, the way that the sunflower does this, and arranging the florets, and how can I apply that to the balcony on a building, so that, each person has both access to the sun and to shade. And what we call this concept is Phyllotaxis. So it's the arrangements of leaves around the stem of a flower. And it's a really efficient way of organizing objects in space. So another question just for the chat. I know that all of you are technologists, but I want you to think, also about nature as well. So at this point, seeing what you saw, if you had to make a decision, if you were to choose nature or technology as a design partner, which would you choose and why? So feel free to debate in the chat, or you could just type in nature or technology and we can take a little count of what you guys are thinking. Pete, what do you think? If you had to choose nature or technology as a design partner, which would you choose?
It would probably depend on my need. If I was looking to be a little more creative, I'd probably go with nature for more interesting shapes. If I had constraints due to the types of technologies needed, or the design, then it might be driven more by technology.
Really good point. Anyone else?
Not yet.
All right, we'll keep it going in the chat. And thank you, Pete, for enriching the discussion. All right, so next we're going to talk a little bit more about biomimicry in architecture, and just kind of biomimicry more generally. So this is an example. This is another rendering, but this building was actually, I've seen the construction of it as well through pictures. But this is a rendering, and this is a building. It's called Abalone House, and it was designed by Exploration Architecture. And this is an example of biomimicry because the roof of the building imitates the geometry of a mollusk shell, and particularly it is a clam shell. And the reason why it is biomimicry is not just because it is imitating the beautiful form of the clam shell, but it's also getting an engineering benefit as well. So biomimicry isn't just the aesthetic, so copying the aesthetic of nature, it's also thinking about how nature designs things more efficiently. So for example, a mollusk shell, its shape makes it very strong while it's also light at the same time. Pete, any comments in the chat?
Yep, we've got two. We have selection for technology, because the contributor knows it could be executed using the things we know how to do now. And then we've got that when it gets complicated to solve with technology, it's sometimes helped to look at how nature has already solved the problem.
So I'm thinking about that design process, maybe like Pete was saying also, that in the ideation phase, when you're trying to be more creative, maybe nature is a place to look. And then once you have a whole bunch of creative ideas flowing, you need to kind of refine it and narrow it down. And maybe technology is a place to do that, and to think about how you could, what's the most efficient design, for example. So I'm going to actually show you in a little bit how I designed the Abalone House using Tinkercad. But before we get into that, I just want to talk a little bit more about biomimicry. So biomimicry isn't just copying forms in nature. It is copying engineering from nature, or imitating it. And it's not just about form, it's also could be materials as well. So for example, designers might look to mushrooms or to underwater plants that have the quality of bioluminescence, which is the ability to emit light through organic processes. And they might think about, how could I solve a design problem using materials inspired by nature as well. So this is actually an older example, even though it looks super futuristic. This is from, I think, 2011. There was this competition for car designers to come up with a concept car that was, better for nature, better for the environment. And they put all these really interesting constraints on it. So one of them is that the car can only be 1,000 pounds. So this was Mercedes' solution to the problem. It was called the Biome. My husband tells me this car is in some of like the video games you guys play as well. But one of the ways that they tried to solve for making the car lighter is they thought about, well, what if we made the lights, like the headlights and the different lights on the vehicle, made them bioluminescent, because then it would be lighter than if you had to have electronic components in the car. So getting back to this concept of biomimicry, you might look to a spider web to think about how could I make a material that's very strong and very light at the same time. I might look at a whale fin to think about how I can make a turbine, the shape of it, more efficient. How might I look to the
foot a couple more
gecko? Oh, sorry, Pete. Any questions or anything interesting in the chat?
Yep. So we've got another contribution for nature, followed for all of its infinite examples of solutions we can explore. And probably on a project that doesn't have given constraints, I would look at nature, but in a project with rigid constraints, I would use tech.
Interesting. So I love the engineering mindset that FIRST Robotics inspires in students. I wish I actually did it when I was in high school, but it's just really cool the way that you guys are thinking, both creatively and also in this cool engineering mindset. So one just other example of biomimicry is looking at the foot of a gecko and how the foot of a gecko can be really sticky and sticky, but not sticky at the same time. And then how can we learn from that in order to make better adhesives or glues, for example? Or even just that honeycomb pattern that you see often, a lot actually in architecture, but also in design, because it's really like a beautiful pattern. What is the bee doing when they are, making this shape? How can we use this shape in order to make things more flexible or more modular? So again, just reiterating what I'm hearing in the chat, that you are all, design thinkers with this really cool engineering mindset. So this is just when I say design thinking, I'm sure you've heard it before. You may have been introduced to this process before in a different way, but this is just one way of representing the design thinking process, which is to really begin with a problem, fully understand the problem, ask questions about the problem, figure out if it's the problem that you think is happening is actually happening. So further defining it, refining it, prototyping, which we're going to create a little prototype today as well. Or you're using also, when you get into that kind of more refining phase, using an engineering mindset. So thinking about criteria and constraints, so the limits of a design. And here's just an example. And again, you can find all of these materials in the lesson that Tinkercad teach, biomimicry and using nature as a design partner. So here's just, I made these more for students who are designing or teachers who are teaching a lesson. But these are just some different categories of constraints you might consider when you're designing a product. So sustainability might be one that we would think about, and you might not use all of these for every project that you're working on, but it's another lens or another way of refining your thinking. So when we think about problems, we might even think about problems within the future of making. So for example, even just particularly in the construction industry, a major problem is the amount of waste that the construction industry contributes to the world. Construction industry is responsible for 30% of global waste. And that problem isn't getting any less because the population of the world is growing. We're becoming more impacted by issues such as climate change, for example. So the industry is really being asked to do more with less while making a better impact on the planet. So one of the ways that the construction industry is starting to think about that is also how can we use more automated processes in order to solve some of the problems that we're facing. So this is getting into my part about why robotics and construction. That's the Instructables robot, by the way. So Instructables is another fun place to visit. It's part of the Autodesk family, like Tinkercad, and it's a place where you can find cool projects to work on. So that's Instructables. But so why robotics and construction? So the things that we are making are changing, the way that we're making them are changing, and also just kind of the way that we work and the way that even companies are organizing workers is changing, and particularly in the construction industry. So when thinking about buildings of the future, when I think of them as almost like big machines. So a lot of what you're learning in first robotics, applying it to something small or smaller like a robot, could also be applied to bigger things like buildings. So has anyone ever seen Ready Player One, that film? I love that film. Pete, have you seen that?
Yes. Yep, I've seen it. And we have a question about Autodesk. Is Autodesk similar to Maya?
So Maya is one of our products.
The Tinkercad.
Yep. So Maya is a computer animation design software, and it's part of the Autodesk family, and you can access it through the Autodesk Education. I can send some links later as well, but it's one of the products that you can actually access for free as a student. In Tinkercad, you can conceptualize a character in Tinkercad, but kind of similar, like if you're trying to use Tinkercad and then design a robot, you can't like join parts in Tinkercad, which you would also need to do for an animation, but you could come up with a concept for a character in Tinkercad and then think about then how you could, kind of rig that character in Maya. Other questions, Pete?
Nope, not yet.
Right, so I'm assuming a lot of you guys have seen the film Ready Player One, and I think it's in the year 2045, which actually isn't long from now. And it presents this kind of like dystopian future where everyone's living in these like tall towers that are like really dirty, and the environment is scary. And I like this actually. For me, it's like the more utopian vision of the future of how buildings might look, particularly as population grows and people start moving more to the cities. So this is a group called Arup, and they came up with this concept for what the skyscraper of the future would look like. So there's modular building components that can be upgraded and rearranged over time. So for example, when you're building a building, if some part of, and especially if you're being super innovative, like the way that you all are thinking, sometimes when you're being innovative, some part of your plan fails. And it would be a shame if you built this beautiful building and then something failed and you had to tear down the whole building. Well, if you think about how you can apply concepts from the manufacturing industry to the architecture, engineering, and construction industry, you can start thinking about how we can build buildings that are more configurable, so that if a part fails, for example, you can just remove that part and keep the rest of the building. So also just thinking about like sources of food. So how can, the facade of the building also, be embedded with like materials like algae that could produce biofuel. Solar panels, thinking about continuous robotic assembly and maintenance of building systems, food production, a membrane. So thinking about building buildings that not only are not having a negative impact on the environment, but how can we build with materials that can actually absorb carbon in order to actually help the planet versus hurt it? So this is just one example to help you conceptualize that concept of how buildings are becoming more like machines, and also thinking about when you are working on a cool construction project, that at the end, you're not just walking away and handing the building over, that you're continuing to gain information from the building that the building owner can then use to keep the building operating more efficiently. So this is an example from a place called, it's a electric company, a big electric company in France, and how they did that. So this is their building in real life. We're about to see a rendering of the building. I think we're there now. So this is before the building was even designed. This is a walkthrough of the building. And what you're seeing now is what we call a BIM model, so a building information model. So you can see the beautiful architecture, but you can also strip it down and see the mechanical components and the electric and the plumbing. And what you're seeing here is thinking about how how the company embedded sensors into the building in order to use those sensors to continue to collect information about the building to help it run more efficiently. So what you're seeing visualized here is these kind of zones of interest that the building owner is able to see in the building through embedding these sensors into the building. And then how the building owner can then think about using that information in the future to maybe, shut off the heat on, one side of the building at a certain time of day so that it's not continuing to consume energy because somebody's, not everyone is there at that moment. Oh, sorry. So that was actually a fun video, but I'm not going to show it right now. Also thinking about how things are made. So for example, thinking about how the architecture, engineering, construction industry can learn a little bit more about the design for manufacturing and assembly industry. So this is an example of a hotel, or no, it's a hospital in Northern Europe. Hotels, hospitals, schools. These are the types of buildings that have very strong patterns to them. So it's kind of a repetitive pattern. Architects don't always necessarily like, having repetitive patterns in buildings. However, the more simple the pattern is of a building, the easier it is to construct. So what you're seeing here is this hospital in Northern Europe. We used a computer program to analyze the building, and it found like 20 to 30 different patterns in the building. We thought about how could we run the program again and figure out some solutions to kind of make less patterns or fewer, make a simpler pattern in the building. So the computer program started to analyze the different rooms, and not only were they able to reduce the amount of patterns from 20 to 30 down to like 5 or 6, they were then also able to then start analyzing those 5 or 6 different patterns and think about how they could.
Kellyanne?
Yep. Hey, Pete.
So what are the colors? Is there a particular meaning to each of the colors?
It's just been to show how there was originally like 20 to 30 different types of rooms. So each different type was a different color. And you probably saw the colors then reduced down to 5 or 6 different colors to show that we were able to simplify the different types of rooms. And then what you're seeing here is the different types of rooms. We were then able to create almost like a bill of materials for each one of the rooms, so that we could think about how you could even start to mass produce these rooms, and even, I think, even get into like things being like geotagged or something at the end too. So it's super futuristic and cool. Does that answer your question, Pete?
So far, I believe so.
Cool. So also just another way that the way that we're making buildings is changing is thinking about, so in the construction industry and all of the waste in the construction industry, so how can we use more additive manufacturing? So for example, 3D printing to make things like components to buildings. The whole building doesn't need to be 3D printed, although it could. We do have a group who works out of our technology center who's thinking about making whole buildings that are 3D printed. But even just some parts, like this is a drainage pit. So how could we, 3D print or prefabricate even some parts of buildings and then bring them, prefabricate them offsite and then bring them on site. Another example, so this is from the Autodesk Technology Center in San Francisco. So this is an example of, so we wanted to teach a robot how to build with bricks. So the robot has like a visual sensor on it, and through virtual reality, the robot is teaching itself how to build something with like Lego bricks, for example. And then the next step was then to think about, after the robot through virtual reality was able to, create millions of different structures in virtual reality, could the robot then do this physically in real life? And the robot could. So the robot could teach itself through virtual reality how to build something in the real world with real bricks. So in this sense, it looks like, we're thinking about like, child's play, but these bricks could be a proxy for something else. So I'm going to show you that now. So this is a company in Australia that is actually building robots that are able to assemble bricks in real life for construction projects. The reason why they're able to do that is because the robot knows what the building informational, the BIM model is. So it's able to locate where to put the bricks because the designers created the design using a building information model. Another example, so this is Skanska, which is a big construction company. I think this example is from Europe. One thing I want you to notice is, one, this is a robot that's drilling, but there's also people around the robot who are working with the robot, so collaborating with the robot to make this building the construction more efficient. So this is a robot that drills. So drilling in a construction project is kind of a really repetitive task. It needs to be really precise. So what are some ways that we can use robots in the construction industry to make the project kind of more fun, so not so repetitive, not so dangerous as well, but humans are still part of the process. So that's not something I want you to take away from this presentation, is that automation is replacing humans in a construction site. Automation is actually helping humans make better buildings. We need to build 13,000 buildings a day in order to meet the demands of the growing population and trends in migration, for example. So how can we do it in a more efficient way? So this robot is actually able to drill things more accurately and do things 8 times faster than a human. But humans are still involved in the process, but humans have different roles in the process. For you, I think this is important to know, because if you're interested in robotics, you might also be interested in the construction industry. Right now, 20% of the workforce in the construction industry is retiring. So even if you're interested in architecture, which is someone who collaborates with the construction industry, over 30% of architects are over the age of 55. So that's another industry where there are a lot of opportunities, and opportunities to continue to learn and grow. And also the construction industry is influenced by these interesting mega trends that you might be interested in as well. So things like big data, AI, predictive analytics, robotics and automation, prefabrication, the Internet of Things, and also 3D printing, so additive manufacturing. It's also creating new roles and new teams and new ways of working that are really interesting and fun. So, you might be someone who manages drones and robots on a construction site, or you might be someone who's the innovation and integration expert who's helping bring everything all together. And also sorry, Pete.
Are there construction industries either in the U.S. or in Europe or Asia that are already using robotic construction techniques and 3D printing?
Yeah, so these examples that we've shown today are actually real. So Skanska is using the robotic drill in its construction projects. A lot of, actually, I'm going to show you. So the next slide actually answers your question a little bit better as well. But the why robotics is kind of being more utilized in the construction industry is the construction industry is shifting from an industry where a lot of the assembling happens on site, is shifting to the assembly is happening off site through the help of robotics. So this is just, when we see the word IC, it's talking about industrialized construction. So right now, 2019, 2020, kind of similar. There's a lot of machine-machine interaction. A lot of the robotics that's actually happening in reality right now is having to do with the manufacturing, so the prefabrication. But in the future, we'll see that robotics are going to be more involved in the assembly. So not just the prefabrication, but what we saw with that Australian company where the robots were actually assembling the building. And then we see way off in the future, not super far in the future, in 2030, we'll actually see more human, machine, and equipment interaction. So for example, not just robots, but also the way that robots and humans are working together with cranes, for example, or other machines in order to make the construction site more safe. So for example, I know that there was a startup company in Boston that was working on one of the issues that makes construction sites unsafe is the stability of a load in a crane. So they made a drone that actually flies around the load and is able to help stabilize the load to make sure that the workers around the crane are safe. or even just thinking about artificial intelligence, so ways that we can monitor the construction site, and then through machine learning, you're able to see ways like, it'll be an alert if it looks like a worker is in danger. And you could be part of that team that's helping keep the workers safe. So I've kind of run out of time, but I'm happy to stick around and show you how I made this building in Tinkercad. Or, I can share a recording later about it too. Pete, what do you think? It would take about 15 minutes, but I'm not sure if we're super out of time.
Yep, I just got asked if we were ready to wrap up, so I think we are out of time for the session right now. Sorry.
No, it's okay. So I will share this later. I'll figure out a way to share it, because these are all just like videos for how you can make this design in Tinkercad. But I thought, well, I had you here as a captive audience, it would be good to think about the robotics in the construction industry. So that's what I had. And then here's just some more resources at the end. So there's Formit, which is another one of our products that is more of a conceptual architecture software that you can learn to use. There's also a webinar series that we are going to be launching in late November, early December, with James Devlin, who is from the New England Patriots. He just recently retired, and his next project is to design and build a gym. So he wants to engage students like you in his design process and kind of learn with you along the way. So that will be happening. We'll be launching it in November. The first webinar might actually be the first week of December. And you can also win prizes too. So we'll have 3 $500 prizes for each winner for each contest. We'll have a few of them. And then just here's some more information about Fusion that I can share with the organizers. So that's it. Thank you, Pete, so much for helping with this and keeping the discussion really rich and interesting.
Oh, you're welcome, Kellyanne. Thank you for presenting for us.
Thank you. Take care. Keep making things.
You too.